and welcome to this session about Blazor at Techorama. I'm really glad to be here. This is my second session today. The first one was about web development with Angular, and now I'm talking about web development with Blazor, a very, very interesting combination, because I guess a lot of you here in the room, and the room is pretty full, I'm happy about that, ask yourself, what is the future of the web? What is this WebAssembly stuff all about? Will C# kill JavaScript? Has it already killed JavaScript? Are we at the beginning of a new decade of very many different programming languages in the browser? We will discuss that. In the next 60 minutes, I will show you the Blazor framework and talk a little bit about why I think it is really important, and it is a little bit of a paradigm shift here in the browser development. My name is Stropek. I come from Austria. I have a small company there. We do primarily software as a service development. And of course, if you do software as a service today, you need a kind of web client. Therefore, I consider myself a full stack developer. I'm doing a pretty significant amount of my work writing code for the client. And this is the reason why I'm very interested in this Blazor technology. I don't have any slides. So we will spend 60 minutes in Visual Studio. I will show you demos. And of course, it's important that you can recap what I tell you here. So I have created this Starship Traveler GitHub repository, which will hopefully come up in a second as soon as my internet is back. This looks much better. Okay, yes, I think we are up and running. Sorry, I don't know what the glitch was. Now we are in the internet. If you want to take a picture, that's a good situation to take a picture. Here you see the entire source code. I updated it today in the night, so it's on the brand new version of Blazor. It works with the brand new version of Visual Studio, and you will find all the source code here, and you can recap the entire demo that I do, because in 60 minutes I can't tell you everything about this whole Blazor stuff. So therefore, yeah, it maybe is worthwhile taking a look at the source code yourself. Good. So let's go here in Visual Studio. Let me show you the kind of solution that I've set up here, because as I told you, I don't want to show you some slides. We are going right into it. This solution consists of a bunch of projects. The first project here is the server. The server is just a regular .NET, ASP.NET Core application. Let's edit the project file to see it. It's a .NET Core 3.0 application, as we expected from a tech conference. It's preview all over. So this is just hosting the project. What does it have to do with Blazor? Well, currently not really anything. It's just hosting the project. But to make one thing very, very clear, the origin of the Blazor project is a single-page app framework. So with Blazor, you are writing an app for the browser. However, Microsoft changed the story a few months ago. Now you can also run Blazor on the server, but that's a different story, and we will postpone that to the end of the session. Currently, at the very beginning of the session, I would like to focus on the new thing based on WebAssembly, and that is a single-page app framework that you can host on any kind of web server that you like. In my case, I host it here in my ASP.NET Core project. Very simple. It's just static files, just a little bit of DLLs and WASM files. We'll take a look at it in a second. And of course, we have a bunch of APIs here that provide demo data for my sample application. Nothing new here. The next one, and this is the interesting one, is my client. This one, the Starship Traveler UI client, it's a .NET Standard 2.0 project, and it's containing the Blazor framework, as you can see it here. It contains the build tools, and it contains the Blazor framework with the newest preview. This client here generates the single-page app. So this client generates the thing that is running in the browser, and the files that fall out from this client project will be hosted by the server component. But you can host it, as I told you, anywhere. If you want, on GitHub pages, doesn't matter. It's just like HTML, JavaScript, and CSS. So this is the client project. And now we come to one of the most important aspects that make Blazor so fascinating for me, and that's the dependency stuff. Take a look at that one. I have a dependency to a project which is called component and to a project which is called modal. The first one, the component one, is not that fascinating. It's just a class library where I put a bunch of reusable UI components into a class library. Why is that important? Well, in nearly all non-trivial projects, you have reusable UI components and you can put it into DLS. That's nothing special. But the modal thing is where it really becomes interesting, because the modal is not only referenced here from the client, but the modal is also referenced here from the server. See that one? And you know, a few years ago, I learned to program Node.js. You know why I did that? Because I was tired of rewriting parts of my business logic for the client in TypeScript and for the server in C#. I didn't like that. Therefore, I wanted to have the same language on the server, on the client. I wanted to use C#, in that case JavaScript or TypeScript, to implement my web APIs, doing, for instance, the validation of my objects there, and use the same logic on the client to do form validation, for instance. And with Blazor, and that's the interesting thing, you can do the same, but now based on C#. So you have just a bunch of business logic, and in my case, it's just a data modal, a little bit of class library. I will come later on to a little bit of business logic. It's just a class library, and in this class library, you can use all the goodness that you know from C# class libraries. For instance, you see it here, I use classes, I use link, things like that. I use, for instance, data attributes. Here you see the required attribute to annotate my classes in order to make it easier to do form validation on the client and validation in ASP.NET Core on the backend and things like that. That's, for me, one of the most important aspects of Blazor. Will Blazor kill all the JavaScript frameworks like Vue and React and Angular? I bet not. Because they are good. I like writing Angular code. I like TypeScript, but I also like C#. But there are a lot of projects out there, including some of our own projects, that have a huge investment into C#. You have built complex class libraries. You have built complex business logics, and you would like to use them. What do you do today? Maybe you know that situation. You just build some kind of service layers on top of it and do everything on the server. And the client is very chatty and talks all the time to the server to keep the business logic in one place in C#. But now with Blazor, you can reuse the knowledge, the business logic, and the class structures. And that's why I think this Blazor stuff is really, really interesting. Today, especially for companies who have a strong investment into C# already and who cannot afford or don't want to retrain all their employees to JavaScript and TypeScript, or who just can't afford translating a lot of C# code into TypeScript to just run it in the web browser. So that's for the business side of it. Good. And yeah, I told you, last but not least, we have our component project here. It's just, again, a .NET standard library. I don't know, how many of you use Angular for more than a year or two? How many are longer in the Angular space? Okay, did you miss Angular component libraries at the beginning when you started with Angular? Well, I missed it. It's now in the package, but it took a while. Module system in JavaScript is not as straightforward as I would like it to be. For those of you who do JavaScript development, you know what I mean. In C#, hey, it's just right-click class library done, and the same is true here for Blazor. Good. So let's start this application. I'll do that, and let's take a look in the browser to understand what's going on. Okay. I call this sample, and we will build it step by step. Starship Traveler. Let's zoom in a little bit and open the network tab here. And let's preserve the log, disable the cache, and reload the whole application. And then we're going to take a look what's going on behind the scenes. Now let's see whether this works. Good, good, good. So my backup plan worked. My phone works as expected. Now let's take a look at the network traffic to understand what's going on behind the scenes. Let's zoom in a little bit. We have some not that interesting stuff going on here. This one is important. Now, you see here we have a little bit of JSON, here we have a little bit of JavaScript, nothing special, but here the story of Blazor begins. We are loading something which is called mono.wasm. This WASM file is an executable in the WebAssembly format. What is WebAssembly? For those of you who are not that familiar with WebAssembly, WebAssembly is a binary standard for a virtual machine. It's essentially a kind of assembler language which is not dependent on a certain processor type. It's an assembler language that can be compiled or interpreted to a concrete environment. And browsers have learned to understand this WebAssembly format. It's a pretty low-level virtual machine. It's by far not that powerful as the common language runtime, for instance. Don't expect WebAssembly to be something like intermediate language. It is much more similar to real assembler language, but it is not platform dependent. So what's going on here? The system is loading the mono runtime, mono like the C# mono, compiled into WebAssembly format and running it in the browser sandbox without a plugin, and that's the important one. Many people, when I show that, immediately say, oh, Rainer, is Silverlight back? No, this is not Silverlight. I did Silverlight, and I learned my lessons with Silverlight, so this is not a plugin. This is native functionality built in the browser because WebAssembly isn't standard. Strictly speaking, you could execute WebAssembly anywhere, not just in the browser. Similar to Node.js. With Node.js, you can run JavaScript out of the browser. Why not running WebAssembly out of the browser? You could, but this is a topic for a different session. Here, we are focusing on the browser's ability to simply run WebAssembly code. Where do you get WebAssembly code from? Well, you take a native language like C++ or Rust, or there are also compilers for Go and so on, and you compile your, in this case, C++ code into WebAssembly instead of an executable, and then you have a WebAssembly. And this is what the Mono team did, is they took the C++ implementation of the common language runtime, compiled it to a WebAssembly, and now it runs in the browser. Okay, granted, it's a little bit simplified, it was a little bit more complex than that, but in 2017, the team did exactly that, and in 2017, we saw for the first time a common language runtime compiled from C++ into WebAssembly, printing hello world in the browser. This is the magic that makes all these things happen. Why Mono, you ask? Well, because the Mono team has the strongest investment into WebAssembly. Could it be .NET Core or whatever the name will be for the next .NET? Of course it could. But currently, it's Mono, and to be honest, you don't have to care because, hey, you're using .NET Standard, and therefore, it's just a runtime. Good. This is the Mono WASM. From there on, take a look what the system is loading now. It's loading just a bunch of DLLs. And these are .NET Standard DLLs. So you really get the .NET CLR, and from that point on, you are running intermediate language code. This intermediate language code coming from .NET Standard libraries is not compiled, it's interpreted. So the Mono runtime is interpreting the intermediate language, not compiling it. You may think, hey, really? Interpreted? That's slow. Not always. Not always. Interpreted code, if you have it, if you do something that is very CPU bound, it is probably slower than compiled code. But you have to keep in mind we live in the browser here. If you have code that is interpreted, you might benefit from things like smaller DLLs, because the DLLs in intermediate language are smaller than WebAssembly modules that would be compiled ahead of time might be. So therefore, you have to consider the load time and many other factors. I'm not saying that in the future, you will not see C# being compiled into WebAssembly, but currently, the current version of Blazor is like it is. You take exactly the DLLs that you run locally on your Windows or Linux machine, and they are run by the Mono engine, and they are interpreted. This is the case currently. Okay, we can scroll down, and we get a bunch of DLLs, and so on, and so on. And then we get the application. This is the application here. The application is currently pretty dumb. It doesn't do very many things. It's just the first step into the world of WebAssembly. Now you know that this Blazor framework is built on top of WebAssembly. So did it kill JavaScript? No, it didn't. Why? If we take a look at the mono WASM here, this thing is running in the WebAssembly environment. And the WebAssembly environment is very limited for what it can do. For instance, your WebAssembly cannot directly manipulate the DOM. Whenever a WebAssembly component wants to draw some pixels on the screen, it has to talk to JavaScript. It has JavaScript interoperability, but it cannot directly manipulate the DOM. How can it communicate with JavaScript? Well, it can call methods, and you have linear memory. So at the end of the day, you have a bunch of untyped bytes where the C# part, the WebAssembly part, can write in some bytes, and the JavaScript stuff can read some bytes. And through this channel, they have to communicate. So we still need JavaScript, and we probably don't want to implement this communication protocol between WebAssembly and JavaScript on our own. And this is where Blazor comes in. So Blazor, the Blazor framework, is using the possibilities of WebAssembly and the mono runtime and adds everything you need for real single-page web development. This is what the Blazor framework does. And this is why we still have a lot of JavaScript components that make that are part of Blazor. Here you see the JavaScript part of Blazor. And whenever you click on a button in your DOM, you're not directly talking to WebAssembly. You're talking to the JavaScript part of Blazor. The JavaScript part of Blazor creates a method call, calls into WebAssembly. WebAssembly calls into your C# code. Your C# logic does whatever it has to do. It has to manipulate some bytes in linear memory, call a JavaScript method. The JavaScript method will pick out some of these bytes and change the DOM accordingly. This is what's going on behind the scenes. Okay? So if somebody tells you WebAssembly is a JavaScript killer, no it isn't. At least not in the moment. Will we see in a few years applications where we just have WebAssembly directly manipulating the DOM? We will see. Of course, it's an obvious choice, but WebAssembly is not final. It's in a very early stage. It's a minimum viable product implemented in today's browsers. So we have to be patient for a little bit to see more powerful WebAssembly. Currently, it does what it does. Good. Next one. Let's add a little bit of stuff into our application. And the first thing that I would like to do is I would like to add or replace the ticket list here. Because the ticket list before just said hello world, and now I have a little bit more power in my ticket list. Let me start the application, restart the application to show you what's going on. So, oh, I didn't close it. Now I can run it. Browser should come up in a second. Yes, we are. Good. This is the new version of the application, and as you can guess from the data, we are talking about a travel agency where you can travel across the universe. And here we just see tickets for some guys called Optimus Prime, Bumblebee, and Kal-El. We'll see. Let's take a look at the code. Here is our ticket list. This is how Blazor code looks like. And let me be your tourist guide through the universe of Blazor. You see, at the beginning, you have some directives here. You have a page directive, which is, at the end of the day, the client-side router. This is your router. You are saying, hey, if the user specifies the URL / or the URL / tickets, please activate this Razor page. Okay. You have dependency injection in it. And we see something which is very interesting. This dependency injection sample here injects the HTTP client class. Yes, this is the HTTP client class that you know and love from C#. So if you have existing code interacting with HTTP client, it will just work on the browser side. How does that work? I mean, WebAssembly can never ever directly talk to the network. That's correct, because Blazor kicks in, and whenever you talk to the web client, to the HTTP client class, The sending of the HTTP request from the client to the server is done via JavaScript. So they have implemented in the background a module that takes your HTTP request for REST APIs, for instance, go through the browser, let the browser talk to the backend, and marshal the result back into your C# objects. But your C# code doesn't see all that. It just sees the HTTP client class that you know and that you inject here using this Razor syntax. Okay, then we have a bunch of HTML, nothing special, a bunch of HTML, and this is the goodness of Razor, right? You mix and match HTML and C#. So you have if and you have for each and all these things. I will not go into the details. I think you understand the principles. The beautiful thing here is if you take a look here, ticket passenger, and then you see here the tickets, and this is just the data binding into C# properties. This is your programming model from now on. If you write Blazor code, you write HTML for the UI layer, and you write C# for any kind of logic and any kind of state. And you can do data binding. This is very simple data binding with the for each and the interpolation and things like that. I think you understand the concepts by just looking at the code. Here, it's getting, again, very interesting. Because this is not obvious. We are using the HTTP client that we already know and love, and we can still use our async programming model. You don't lose that. You might think, oh, what does that mean? Do I finally get multiple threads in the browser? No, you don't. You get async programming, so you can do async await, but you can't do parallel programming. This is not possible, okay? But async await works as expected. So if you have a class library that already uses tasks and the task-based programming model and async await, you can still use your code. It will just work. Also, things like that, where you take link, for instance, it just works. You don't have to do anything. Why? Because it is a common language runtime. Now, I learned C# with the very first versions of the first technical previews, and I love C#. I learned JavaScript quite a while ago, and I know TypeScript very well. But at the end of the day, if I have the choice, and if I have to make the choice, writing business logic in C# or in JavaScript, personally, I go for C#. And therefore, I am pretty thrilled about the possibility to write non-trivial business logic in C# running in the browser. We can discuss whether it's already there. Well, it's not, it's a preview, but it is an interesting option for the future or for experiments currently. So this is how such a Razor page looks like. So you now understand it's just HTML and therefore also just CSS if you would like to use CSS. It's mixed in C# code, and we just have all the things that we know from C#. By the way, if you don't like mixing the logic and the view in a single file, of course you can separate these things, but for the sake of the demo, so it's easier for me to describe the connections between the view and the logic, I put it in one file. But of course you can separate these things. Good. Next step. My next step will be here. First, we take the ticket card and the QR code, and we move it to the components. I will do a walkthrough in a second, and we take the ticket list here to the pages. Okay, and overwrite it. Good. To a clean solution just to make sure and rerun it, and I will show you in a second what our application now has learned, and then I will show you some interesting aspects of the code that I just added to our application. Good. So loading our tickets. We see. We have 3 tickets for Optimus Prime, Bumblebee, and Kal-El, and Optimus Prime is traveling from Cybertron to Earth in 2007 and things like that. This is what we see. Now, let's take a look what happened behind the scenes. If we take a look here in the ticket card, what you see here is now a Razor component which doesn't have a page directive on the top. Instead, this is called ticket card, and if we now take a look at the ticket list, we now can extend the language capabilities of HTML by creating custom reusable components, and that's the point. Very similar to Angular and other libraries. You essentially create a Razor component and you get a new HTML element. Additionally, you can do data binding, as you see here. So in my case, I encapsulated the visual representation of a ticket into the ticket card class, Razor components. And I give it the data about the ticket, which I got through an HTTP REST API call via data binding. Now let's take a look in our ticket card. The ticket card, contains a bunch of HTML and a really trivial business logic, nothing special. But here again, I use another visual component, a visual component which generates the QR code for my ticket. See that here? So the ticket QR code uses a method. Oh, I didn't zoom in very nicely. Yeah, this should work. Here we call a C# method inside the data binding to our visual component and generate the link, which should be represented by the QR code, because then the user can use this link, take a picture on his phone and gets the ticket. I think you get the story. Let's take a look at the QR code here. Very simple. In this case, I'm using a static QR code, but I think you get the point. And I'm just using the parameters here. The parameters, they enable data binding. By adding the parameter attribute here, I enable data binding for the property ticket link so that the user of my UI component can do input data binding. Not that difficult. I think that should be okay for you. Good. So, what happens? What happens in the background? I mean, we are creating components that can be reused. Let's take a look what the compiler did with all our code. If we take a look at the client and go into the object directory and debug and net standard and Razor declarations and pages, and here we should see the ticket list. Where do we have the ticket list? This is the ticket list. And what you see here is what's going on behind the scenes. Whenever we create a Razor component, what we essentially get from the Blazor compiler, it compiles our HTML code into C#. And therefore, it's very similar to what you might know from Angular, for instance. In Angular, you have HTML code, and the Angular compiler compiles the HTML, the Angular template code to be more specific, into JavaScript. Here, Blazor, the Blazor compiler, compiles our template language, Razor, into C#. So what we see is a class derived from component class, and if I scroll down a little bit, we also see, as you can see it here, our business logic. It's just injected into the generated class, okay? So let's take a closer look at here. Object and debug and net standards and Razor and pages and ticket list and here you see it. This is now the compiled HTML code into C#. So at the end of the day, the HTML tree, the DOM, is generated by running C# inside of WebAssembly. The process is called building a render tree. In C#, Blazor builds the render tree. The render tree is put into linear memory, given to JavaScript, and the JavaScript part of Blazor will then construct the DOM tree from that. Okay? So the HTML that you write looks like HTML, but at the end of the day, the HTML is compiled into C#. Good? Very similar to Angular. Those of you who are Angular developers, you should have a kind of déjà vu effect here. As you can see, the business logic, for instance, the for each statement from the Razor code is just injected into the code. Nothing special here. Good. This is what's going on behind the scenes, and now you can easily understand how it is possible to use a custom UI component from one Blazor site into another Blazor site, because at the end of the day, everything is just a class. And by adding the HTML element here, It's just creating an instance of the class, and data binding is just passing of some arguments between C# code. Good? Good. Next step. So let's take the time selector, move it to components, the ticket QR code and the ticket card to components. Yes. Did I copy the time selector? Yes, I think. Yes, I copied it. And finally, the new ticket list here to pages. Good. Let me rebuild my application. And then we will take a look what new tricks our application just learned. Look good. Maybe make it a little bit more smaller. So now we have the possibility to switch between past travels, so people who traveled in the past through the universe, and upcoming travels. So Optimus Prime, Bumblebee, and Kal-El, I think this guy is called Superman, they already traveled with our travel agency, and if I say upcoming travels, then we will see that Mr. Jake Sully will travel from Earth to Pandora, but it will take a while until he will travel through the universe. The important thing here is this one, okay? I would like to talk a little bit about this control that I implemented here. Good. Let's stop it and go here in the time selector. The time selector here in this case is just two buttons with a little bit of classes and CSS around it. But the important thing with the classes, I would like to show you that here, is that the CSS classes are generated based on C# logic. For the Angular developers in the room, this is just a class binding, and this is exactly what it is. Depending on the business logic, you can add CSS classes and therefore format it accordingly. So if we switch between the two buttons, we visualize the active button by just changing the CSS code, the CSS classes. Additionally, we have something interesting here, because in the ticket list, we now need to understand when we have to do the refreshing of the ticket. Okay? When do we have to switch between time future, or time past? And now if we take a look at the time selector, we see something new. Bind minus time. And this syntax is now two-way binding. So we are binding the enumeration, time, future, or past, two-way between two Blazor components. We have the Blazor component for the selector. It will define whether we want to see the future or the past. And we have the C# property down here. And of course, we can react on changes by refreshing, by reading new data from the server, doing a new REST API. So this is two-way binding. Let's take a look how this is implemented in the time selector. And you can see it here. On the one hand side, we have a parameter which is called time, and on the other hand, we have a parameter which is called time changed. And this is an action, as you can see it here. So if something changes, switch to past, we just call the action, and this is essentially the signal for the parent component that something has changed. This is how you implement the side of a two-way binding. Of course, things like forms and so on, they come with a lot of two-way binding features built in. You can expect that, but this is how it works in the background. Just actions, and for those of you who are C# developers in the audience, hey, this is a concept that we already know, and we use that every single day, actions. You don't have to learn new things like, I don't know, TypeScript, function types, and promises instead of tasks. You stay with what you know, and always keep in mind, this is .NET standard code. So if you have existing C# code, you can just reference the class library, and it will just work. I would like to complete this part of the sample by pointing your attention to this part of the code here, especially this line. In this case, via two-way binding, we are changing a property from a child component by doing this action call. It happens that Blazor will not recognize if we change, for instance, the list of tickets for which we have a data binding to display the tickets here. So sometimes we have to help Blazor, and we have to manually kick in the data binding mechanism. Whenever Blazor doesn't automatically recognize that something has changed, for instance, a web API request is finished, then it will display the UI automatically. But if something happens that Blazor doesn't recognize as, hey, something has happened, you can always call the method state has changed, and then Blazor will trigger the data binding mechanism and will change the DOM accordingly. Okay? How does it do that? Well, it builds a new render tree, diffs the render tree, finds the differences between the old and the new render tree, and sends the changes that are necessary via JavaScript to the HTML DOM. So the change detection is done in C#, not in JavaScript. This is the important thing here. Okay? Good. Let's take the next step. Let's, just to make sure, clean the solution and run it. Here's the browser. What new tricks did we learn here? We can now click on one of the tickets and we will see that Optimus Prime traveled from a rather unpleasant planet, Cybertron, to Earth, or we can go back. Let's see what Bumblebee is not that interesting. Here we had somebody travel from Krypton to Earth, for instance. So the point is that this new thing now contains a router, and this is what we expect here. We can navigate to the ticket details. This is done in Blazor using something like this. As you can see here, at the top of the Razor component, you see the page, and this page contains a variable part, ticket ID. You can take a look at the rest of the code yourself, nothing special here. And here you see, again, the parameter attribute with the ticket ID. So you can take the ticket ID later on when you do the HTTP request to get the details about the ticket. You can take the parts of the URL just as you are used to in other parts of the of single-page-app frameworks. So this is a client-side router. Why does that work? Well, if you take a look at the root index.html, you will see that in the index.html we have this base href attribute here. This base href tells the system that all the routes which are relative to this slash, so in our case all the routes, are handled by the client-side router, and therefore Blazor kicks in whenever the URL changes, and it is a real single-page app framework. There is no communication in terms of reloading the application whenever you change a route here. That just works, so we have now deep links enabled. However, please keep in mind that all the tricky parts of single-page apps in terms of client-side router still apply. I can show you why. If I reload this page, this works, and we will go to this package. But this only works because we host it now in ASP.NET Core. If we would host that one, for instance, on GitHub Pages, and we would press F5, we would get a page not found error. Why? Because on the server side, there is no route like that. Understand what I mean? So what you have to do if you host your Blazor single-page app on a static web server, you have to implement a 404 custom page and tell the server, hey, if you see a route that you don't know, just ship index.html, and believe the client that the JavaScript, which is in this index.html, will care for the proper routing. Okay? If you host it in ASP.NET Core, you don't have to care about that. It's built into ASP.NET Core, but if you host it on your own static web server, this is necessary. Good. Next one. We still have some interesting things to do. So, step 50, Razor compiler. We need the network. The flight network should be in the component section. Yes. The flight plan should be in the modal section. And the network Razor should be in the client section. Exactly. Yes, this is good. And finally, I need to go to the startup here and point out the first thing that is important. As you can see here, this is the startup class for the client-side Blazor, okay? This looks very familiar to ASP.NET Core developers because here you have a configure services method and here you have a configure method. And in the configure services method, you can use dependency injection as you are used to from ASP.NET Core. So in our case, we are implementing a flight plan. Flight plan is just a little bit of business logic that finds out from which planet I can fly to which planet. This is what the business logic is all about. And in my case, I implemented an interface to be able for unit tests to mock the flight plan. Okay? So if I test a UI component or my classes in C#, I don't need to provide the full flight plan. I can easily mock it, and therefore it's important to know that we have dependency injection built into Blazor. I'm missing a using here. I will add the using. And please also note that my flight plan, this is now non-trivial business logic. I will not go into the details here. It is a little bit of business logic that we use in our code. But the point is, this non-trivial business logic is part of a class library that is not Blazor specific. This modal library contains now non-trivial business logic with a little bit of sinus and cosinus and things like that. I'm just calculating a bunch of coordinates. You will see what this generates in a second. And this business logic, as I said, is not Blazor specific. You can use it in a command line app, in a WPF app, in a WinForms app. You can use it in the back end. You can use it in the front end. And I think at a more higher abstraction level, this is the most important message that you should take away from this session. If you have an investment in C# for business logic, data structures, knowledge, and so on, then Blazor might be very interesting for you. Good. Let's clean the application, clean the solution, and run it. Let's hope it works. Go to the flight plan. Oh, yes, it works. So you see, I did a little bit of application. So if I want to know where can I travel from Earth, for instance. Oops, I pressed the wrong button. I'm sorry. I wanted to zoom in, but I closed the window. Not a good idea. So let's go back here, flight plan, and go here and just like that. And as you can see, this is what the flight plan does. It just calculates a bunch of points and visualizes it with some arcs in this case, or Bezier curves, for instance. This is what my business logic does. So I didn't come up with a better idea for business logic, but I think it's kind of funny. Especially, it's funny that we can travel from Krypton to Tatooine. I don't think that this is really possible in real world, but in my Starship Traveler, it is possible. I wanted to show you this flight plan is already, you already saw that, but the flight network is another thing that I would like to point out here. Please keep in mind what you just saw. You saw the different planets which are served by our Starship Traveler company. And of course, I cannot hard code all the planets in HTML. In my case, I decided to go for a template-less component. So what you can essentially do, if you want, you can directly derive from the base class component base. You've seen before that HTML templates are just compiled into C# classes in the background. Therefore, you don't need the Razor template if you don't want it. If you have a page which is 100% built from application logic, you can directly derive from component base and build the render tree yourself. So if I scroll down a little bit, you see that this is, okay, it's not the most beautiful code on earth, but it works, okay? You can open element, you can add attributes. In this case, I'm adding some SVG stuff. You can do for each, and you can add classes and things like that. This is readable. This is also writable. So if you have algorithm-driven use cases, user interfaces, then you don't need the template if you don't want it, okay? Of course, we could write the same with the template. All the other things, for instance, routing, dependency injection, work as expected, except that we don't use these directives at the top of the Razor page. Can you remember? @inject HTTP client and so on. But now we use plain C# attributes. This is possible because the Razor templates are, at the end of the day, translated into C#, and so the @inject directive turns into attributes nevertheless, always. Okay? And here you also see the dependency injection of my custom business logic, which come from my generically usable class library, in this case, our flight plan logic with calculating the different points. Good. Next one. We are reaching the end. Let's add the booking page, exactly, the booking page to our client. Let's rerun it. And now we reach the final item. Oh, sorry, I forgot to do one thing. This is all preview software, so sometimes you have to do some things that it shouldn't be necessary to do them, but we have to do them. So I'm just cleaning the application and rebuilding it. Good. So now you see this is just an entry form. We want to now book a template, book a ticket, for instance. Now, in my case, I have the Mr. Luke Skywalker, and he wants to travel, let's say, from Tatooine. Let's Tatooine, and he wants to travel to Earth, for instance. Let's make a mistake and forget the passenger name and click on it, and as you can see here, the passenger field is required. This is the point that I want to make here, form validation. Blazor contains a form validation framework. So essentially what you do is you are creating forms and you add a data annotation validator, and then you can here add a validation summary if you want. And what it does behind the scenes, it respects your data annotation attributes here. And of course, the same data annotation attributes can be used on the server side to do ASP.NET Core validation of the incoming modules. So this is the point that I want to make. Form validation on the client side and incoming JSON validation on the server side through the same classes and the same code. This is what I'm doing here, and yeah, the new form validation framework in Blazor has been a recent addition to the Blazor framework, and it really comes in handy. This is this example. Last one, let's add the JS interrupt stuff. The book ticket is going to be updated here. Yes. Then the flight plan is going to be updated here. Yes. And the index.html is going to be updated. Good. Let's take a look in the index.html. My last demo consists of two important things. The first one is a little bit of JavaScript. Yes, I added it directly to the index.html. As you can see, I add to the window a top-level object, Starship Travel, and it contains a confirm JavaScript and an alert JavaScript. And you can guess what I want to demo. Interop between JavaScript and Blazor. That's now pretty simple, because if I go here, you can see that it's pretty obvious how to call this thing. If I want to call into JavaScript, I just say JS runtime invoke async. See the async programming model here? And I just say show an alert or ask for a confirmation. This is how easy it is to call a JavaScript method from Blazor. And believe me, it works the other way around too. Very simple. If you want to call a Blazor method, a C# method from JavaScript, that's really a one-liner in JavaScript. So if you have existing components written in JavaScript or TypeScript, even if you bought it from third-party vendors and they are just HTML and JavaScript, you can continue to use them with your new Blazor stuff, because you can call into JavaScript and you can do whatever you want in JavaScript. But I did something else. Let me show you the result and then show you how I did it. And hopefully this is the final demo and it still works. Let's run the code. Go to book tickets and let Mr. Luke Skywalker travel from Tatooine to Earth. Unfortunately, we don't offer a direct service between Tatooine and Earth. We don't have a direct shuttle yet, so therefore Mr. Luke Skywalker has to switch between our starships. So we click on submit, and this is the JavaScript interop. You see it? No direct route. We can offer Tatooine, Krypton, Earth. Oh my God. The comic fans in the room, please don't throw tomatoes at me. Yes, I know Tatooine and Krypton and so on. But yeah, in our universe, Mr. Luke Skywalker has to take this route. This is the JavaScript interop stuff. But there is something even much more interesting behind this small little dialogue. The question is, how did we find out that from Tatooine you have to go to Krypton in order to get to Earth? In the real world, we would have to implement shortest path analysis business logic, but I don't want to do that by hand. Therefore, I just went to NuGet and looked for a Dijkstra algorithm component. It is a DLL written in C# that has never been thought to be used in the browser or on the client. But still, I just installed it. So if we take a look here at the project file, you can see that I imported Dijkstra.net. And that's the point. I just use it on the client side. I use business logic from NuGet because it is a .NET standard library, and therefore I can do the shortest path analysis, not by talking to the server, but I can calculate the path on the client. This, I think, is a very powerful thing that you see in this demo here. You write C#, you use existing business logic, you interop with JavaScript, all that directly in the browser based on standards and platform independent. So now we have a pretty complete Starship Traveler example, and you might ask yourself, okay, I've seen a lot of goodness. I am interested. Can I use it today? No, you can't. Well, you can if you want to just try out things. But Blazor is a preview. It's not experimental anymore. Microsoft committed themselves that Blazor will be a project. It is in preview. It's not released to manufacturing already, but it is a preview. It's no longer experimental. When will you get all these things? Well, not in the near future. Probably, I guess, sometimes in 2020, we'll see. But Microsoft did a very interesting move. They decided to add a flavor of Blazor, which is called server-side Blazor. And I would like to show you that one with a different project here. Now, this project is not our Starship Traveler. It's more, yeah, it's a more the boring startup sample, but this is not the point. I go here to the network stuff, and I click on counter and hit click me here, and I have to reload it. Give me a second. Here. And this is my application. Now let's take a look. Where is WebAssembly? It's gone. The idea of server-side Blazor is that you can use exactly the same code that I've shown you in my Starship Traveler example, just Blazor components, Razor components are they called here, and you can run them on the server instead of the client. What did I tell you about WebAssembly? WebAssembly cannot directly manipulate the DOM, right? Therefore, Microsoft has had to invent a protocol with which the WebAssembly stuff can communicate with JavaScript so that JavaScript changes the DOM. Now what they did is they took the part that runs on the client, rip it out, put it on the server, and add a little bit of WebSockets between it. So the render tree is now not going from WebAssembly to JavaScript, but it's going from C# on the server via WebSockets to the client to JavaScript, changing the DOM. Get the idea? Same protocol, same idea, same code, now running on the server. And the big difference is that we are now really on the server. Therefore, there is no WebSockets anymore. I can easily set a breakpoint. I can run my application in the debugger this time. The WebAssembly debugger is still a little bit featureless. Let's put it that way. I will not demo it because of time constraints. But here, everything is fine. I go to counter, I click on it, and I hit the breakpoint. I am here, I'm at the breakpoint, and don't misunderstand what you see here. This is not browser debugging. This is now server-side Blazor, and I'm now debugging ASP.NET Core on the server because the click was translated via WebSockets to the server, and there it runs. And this flavor of Blazor will come earlier. It will be part of .NET Core 3, so therefore, when .NET Core 3 comes out, you can use this stuff in production, and hopefully in 2020 you can take your Blazor components that you write between 2019 and 2020 and just compile it to WebAssembly and then also run it on the client. Sometimes, if your client has a lot of CPU power, you might want to use WebAssembly on the client. Sometimes, if your client has less CPU power or you don't want to give the business logic to the client, you run it on the server and you don't have to invent the protocol in the middle yourself. This is done by Blazor. I personally think that Blazor is really a very interesting application, especially if you have a strong investment into C#, if you have existing knowledge, if you have existing component like the Dijkstra algorithm here. Is it already a JavaScript killer? No, it isn't. It needs JavaScript to talk to the outside world. Has it broken the monopoly of JavaScript in the browser? Definitely. Up until now, whenever you want to write code for the browser, you need JavaScript. Even if you take TypeScript, you have to compile it down to JavaScript. This monopoly has been broken with WebAssembly. Now you can use C# and many other languages, because languages like C++, Rust, Go, and so on, they all are looking into this option of compiling or interpreting their stuff in the browser based on a runtime that is running inside of WebAssembly. So I hope this session gave you a clearer picture about what WebAssembly and Blazor, how this combination is working together. I hope you now have a clearer picture whether this is an interesting technology for you. I invite you to take a look at my little Starship Traveler example. I hope you liked it, and maybe you can find some interesting connections between various stars and Earth. Thank you for coming. If you have any questions, come to me to the front. I'm more than happy to answer them. Thank you very much.